Hey guys, welcome to PCMINR.com and you're watching the video on distance and displacement by Sonal Gupta. In a previous video, we talked about motion and rest and motion are relative terms. Now we are going to talk about the parameters that are used to describe motion, and they are the distance and displacement. First one. Now, what is the difference between distance and displacement? See, for a layman, distance and displacement are the same, but in terms of physics, there is a very important distinction between the two. So, let's say that when you go from your home to school, you take up this path 1, right? So, this is path 1. So, you went from here, you picked up your friend, and then you took this road, then you took another friend on the way and going here. So this is path 1 you have followed. Another option is that you can follow this path to go to school, which might be a little shorter than path 1. But the shortest distance between your home and school is this, the path number 3, which you're not taking for whatever reasons. But in every case, you see that the length of the path you're following is different. So this is path 1, the length might be, say, 3 kilometers, and you took the path 2, then there the length might be 2.5 kilometers, but the shortest distance between your home and school is actually 2 kilometers. So what is the distance here and what is the displacement? So now we can say that the actual length of the path that is covered from the starting point to the end point is called distance, while the shortest distance between the initial and the final point is called the displacement. So this means that your distance, this parameter, depends on the path followed. Whatever path you take, every time the distance is different. But displacement, this parameter is independent of the path followed but depends only on the initial and the final point. So whatever route you follow, we want only the shortest distance between the initial and the final points. So displacement will always be the shortest distance. And distance can be equal to the displacement if you're following this shortest route. Otherwise, your distance is more than the displacement. So I hope you've understood what is the basic difference between distance and displacement. Let's take up an example here. Like you go for a walk in a circular park and you start from the point A, right? And while walking, you got a little tired and you stopped here at the point B. Now, this point B is diametrically opposite to the point A. So here is my point B. How much do you think is the distance covered and displacement made by you when you are at point B? So now carefully see and try to understand the difference between distance and displacement here. See, the distance covered will be the length of the path you are following. Now, what length are you following here? You go from A to B. The length is equal to half of the circumference of this path. So your distance is half of the circumference of this circular park. And if the radius is r, then the distance covered is pi r. But what is the displacement? Since the displacement is the shortest distance between the initial and the final positions, so this is going to be the shortest distance, that is the diameter, and that is equal to twice the radius. So you see the distance covered in half of the circular park is pi r, but displacement is 2r. So there's so much of difference between the distance and displacement. And now you continue walking and reach the starting point A. So after taking the entire circle, you are back to the point A. Then how much is the distance covered? It is the complete circumference of the circle because you've taken the full round of this circular park. So you go from here, then you took this complete round. So you have covered the actual length of the path as circumference of the circle. And since we take the radius as r, so the distance is 2 pi r. But you know what? How much is the displacement you have made? Well, there's a shocking answer to this. It's 0. Now, why is this 0? Because I told you displacement is the shortest distance between the initial and the final position. And since here your initial point coincides with the final point, therefore the displacement is 0. I have another example here where your displacement won't be 0, but still it will be different from the distance covered. Now see here, a particle starts from point A, it goes to point B, covering a distance of 3 meters. Then it goes to point C, covering a distance of 4 meters. And the final position is C, and the initial position is A. So if you measure this hypotenuse distance, it's 5 meters. You know how we calculate this? Here, what is going to be the distance? The distance is going to be again the actual length of the path covered, and that is AB plus the length of the path BC. So it's 3 plus 4, that gives you 7 meters. Simple. But what is the displacement? Now we know that displacement is the length of the hypotenuse because it's going to be the shortest distance. So we say that displacement is the length of the hypotenuse AC. And how do we calculate AC? You've done Pythagoras theorem in maths. Therefore, we can find out here AC square is equal to AB square plus BC square. So that gives you 9 plus 16, 25, and therefore your AC is 5 meter. So you can make out that how your displacement is coming out to be different from the distance every time, right? Now, one more thing, precisely, if I would say, precisely the displacement is nothing but distance plus direction. So displacement is something where the direction also matters. So when you say distance plus direction, then that gives you displacement. So here this direction of this arrow matters. You know, if you will take the point C, so if you come back from C to A, then your displacement is not going to be 5, it's going to be 0, because the arrow which is pointing here in the given case, it is just opposite to the one if you come back to A. So the direction matters in case of displacement. So let's just draw a comparison between distance and displacement. First of all, distance is a scalar quantity because it's just a number without direction, but displacement is a vector quantity which is a magnitude along with a direction. Then displacement can be 0, it can be positive, it can be negative depending on the direction of the moving object. As I told you, if you are going towards right, it is positive. If you come back towards left from the same path, your displacement is going to be negative, and hence when you reach at a starting point, it comes out to be 0. But distance can never be 0 or negative. So if an object is moving, it will definitely cover some distance, though displacement, even if it comes out to be 0. That means distance will always be greater than or equal to the displacement. Sometimes if you follow just one shortest path, in that case distance and displacement are equal. Otherwise distance will always be greater than displacement. And last one is that both of them are measured in the same SI units, that is meters, because finally they're giving you the length of the path. I hope you understood the difference between distance and displacement, and that is all in this video. In the next video, we shall continue with the uniform and non-uniform motion. If you find the video helpful, Please subscribe, like and share, and follow us on Instagram and Facebook at PCMINR.com. Thank you.